We're going to kind of get kick started on the second part. My second topic for today is on shifting gears to observability to enhance site reliability engineering practices. So in my earlier introduction to site reliability engineering, I was talking about there is a shift from monitoring to observability, right? We're going to deep dive into observability because that's the only way that we can get a lot more insight beyond just the monitoring aspect of it. We really talked about the site reliability engineering hierarchy. You start with the basics of monitoring and then just move up the value chain. So we're going to talk a little bit about observability and how we're going to achieve that goal. From an agenda perspective, we're going to talk about the introduction to this topic, why observability is becoming a very important agenda for site reliability engineers. We're going to talk about the SRE context setting. That means how is SRE going to get benefited with observability? That we have talked a lot about toil, SLOs, technical debt reduction, anti-fragility. How is that going to fit in? How do you shift gears from monitoring to observability? Because I think a lot of companies globally are well versed in monitoring aspect of it, but we have to go beyond to start thinking about parameters that will help us to build observability. What are the maturity models? Because a lot of companies ask us, okay, in terms of the maturity models, where do we lie, right? Are we at level 1, level 2, level 3? So we have given a little bit of an insight on different maturity models. We picked up one of them that I'm going to explain. And then a very important concept that is emerging these days is the world of open telemetry, right? And it's changing gears, whether it is a proprietary product that you have or open source products. Open telemetry is becoming a big de facto way of looking at observability. So we're going to talk about that. Then, what are some of the challenges in looking at observability, right? Easy said than done, right? So you can get all the tools in place, but how are we going to orchestrate the pipeline? What are some of the do's and don'ts? What are the things that we need to be aware of before we jump into the bandwagon? And then what are some of the recommendations, right? I just want to be very clear. I'm not going to give you a very recommended tool perspective because as a consulting organization, we think that every tool has got its own merit. But I'm going to give you some of those facts that you need to keep in mind to picking up your tool of your choice, right? Because every corporate has got a center of excellence or tool chain team that decides and does a due diligence to pick up the appropriate tool. So we will keep it up there and then see how that can be more meaningfully done. I hope that is what I want to cover in the next 40 minutes or so and take you into that particular journey of observability. So this is all good. So you know about me. I've done the SRE practitioner and the Observability Foundation, which is again a 2-day course, right? In the earlier resource, I showed you an SRE Foundation is a 2-day course from the DevOps Institute. Then the SRE practitioner is a 3-day course. And this Observability Foundation is a 2-day course. So what we have seen is that if you are a site reliability engineering person who wants to be embarking on the journey, that's the next logical step. A lot of our clients go through the SRE Foundation, SRE practitioner, and then observability because you would have all the principles and practices that you can understand and then tie a knot on that, right? Now, I want to start with the context setting, right? Why observability, right? So if you look at the cost of downtime, because this is becoming a big issue at a board level, right? As I told you, downtimes becomes a nightmare and people don't want to feel that they are losing revenue, right? So this was a report from Splunk in 2023 where they said downtime is getting more expensive. Now, when we say expensive, how expensive is it, right? So nearly 2/3 of an organization that were interviewed as part of that report says that every hour of downtime costs more than $150,000. I mean, at an average, right? It could go beyond that as well. But $150,000 is a staggering amount, right? And in fact, very interestingly, when I was doing one of the client engagement, they were looking at resourcing and I told them we need to hire at least two site reliability engineers, right? And they said that no, what is the business case? How can we fund it? So I put forward this calculations saying that what is the cost of downtime, If the cost of downtime is 150,000, and if I look at 2 hours of downtime, it's about 300K. Rather, I would invest that 300K to get two site reliability engineers, going back to that survey of the salary survey that I talked about. And if I'm able to reduce this downtime, will it not make sense, right? So I think it's a very important part as a site reliability engineer to prevent some of those unplanned outages. Because frankly, today, everybody is talking about high availability, either on clustering, fault tolerance, looking at microservices. There's no downtime. I think that's where the whole world is shifting to. So the cost of downtime can become a huge repercussions in a lot of organizations. And that's where I think being predictive becomes more important, right? People have gone away from that reactive to proactive. But if you need to get into predictive, you need to get a lot more insights beyond just the monitoring part. And that's where this section of observability is going to be talking about those elements, right? Now, as I told you in the first session, that site reliability engineering's focus is primarily on reliability and resilience, right? The ability of the system or applications that is able to fulfill its obligation without breakage, but also on the resilience part of it, right? When I say resilience, ability to bounce back, right? You would have been encountering this situation where every time a major incident or a P1 incident happens, the first and foremost question that the business is going to ask you is, what is the guarantee that this will not happen again? Now, you can say that, on a best case scenario, we have done a problem management root cause analysis, but remember, your root cause analysis is not a one-to-one mapping. There could be one to many reasons something failed. So it is not possible to nail down all the issues when it comes to the root cause analysis. So there is always an opportunity. There could be another reason something failed, so you cannot nail down that this issue will not reoccur again, right? So if I look at the overall life cycle within the space of agile, DevOps, SRE that we talked about, it starts out from the product backlog or new features. Remember the product backlog where you have a set of features. It could be non-functional features as well. And then you decide on a sprint backlog of how much of these features should go into production every 2 to 4 weeks, depending on your sprint frequency. Then there is an engineering team that starts looking at how things are going to be done. Now, the question is, if you go from the right to left, right? I'm just going to go through this cycle. The product backlog features, as we start to drive, we also need to look at error budgets, right? Error budgets is basically an opportunity to experiment. So, for example, if your system is unstable, you will stop deployments. It's called consequences. In fact, LinkedIn for 2 years did not do a single release because their system is highly unstable, right? So inculcating the error budget will also means that we as a team, like the product owner, Scrum Master, SRE, DevOps, everybody understands the skin in the game because we will halt deployments, right? If I ask the development team to stop deployments, they're going to come from running from pillar to post, that they will not allow it. They would want that to be released on time, and they don't want to hamper the delay in releases, right? We also need to look at instrumentation, right? Which is basically instrumenting a piece of code, because typically what happens, even with the best of monitoring of your infrastructure monitoring or app monitoring, you cannot monitor everything, right? In spite of all the best effort that you have done in people, process, technology, something will break in production, which is what I call as wisdom of production, right? You learn really on the ground by having goof ups, right? I still remember that all the goof ups that I've done as part of my career, I'll never forget, right? It's a lessons learned. But the point is, sometimes with the wisdom of production, what you understand that is my monitoring is not covering everything. So what is the likelihood that the next time such thing happens, it should be able to push into the error log, right? So that's where I think the whole concept of instrumentation becomes important. Instrumentation is where the developers are entering the piece of code into that system so that the next time it is pushing to the error logs. So you already have monitoring, observability, telemetry, which is what we are deep diving in. And if there is an issue that has been reported, it goes to the service desk. Then we do a blameless postmortem. Then we do kind of also do the triaging to see how can I prevent such issues from happening in future. And then there is a engineering review, right? So this is the overall scheme of the life cycle part of it. We have touched about all of those elements. So I hope this gives you a clear picture of the life cycle as far as how SRE is getting involved. Now, for me, the most important part is what is the big puzzle that we are solving, right? As a site reliability engineering person, what are you really passionate about? For me, I think this is a very important slide. Now, let's say if I plot between the data available to the understanding, because I don't think there is a dearth of data, right? There is so much data coming from all different parts. Now you need to have a meaningful interpretation of the data, right? At one time we talk about improving the signal to noise ratio, right? So your alerts and thresholds that are giving you a picture should also indicate how am I doing it overall. That gives me an understanding about what else could go wrong, right? Now, if I look at this graphic or this matrix, the question is you have unknown knowns, you have known knowns, you have unknown knowns, and there is one part called unknown unknowns, right? So this is part of where we have no idea about what will happen. And this is where this becomes a little tricky, right? When we have something which we don't know what will happen, then there is a huge problem that would become surfaceable. In fact, what I tell people is that while it's okay that you manage your P1 incidents or P2 incidents or priority 1 and priority 2, what you don't understand is your priority 3 tickets or 4 tickets might be the undercurrents. Now you don't see that loomingly big, but as you start to hit that ceiling, that will come to a position where it will haunt you to a greater extent. So as a observability puzzle, the merit is to understand unknown unknowns, because if you start understanding unknown unknowns, then we are probably getting better prepared, right? We have done the puzzle to a certain extent with monitoring, but I think the biggest opportunity is to look at no idea what will happen, right? So that's part. So if I look at that into the context of core analysis loop, you need to start understanding you have a lot of data, which we'll talk about: metrics, events, logs, traces. There's so much of data, right? So the first and foremost question that you need to ask when you're doing observability is, what are you trying to understand? Is it a patterns of behavior? Is it a part of the focus around certain log files, issues? Are you trying to fix something? Are you trying to prevent something from happening? And then you need to visualize all the telemetry data. Like the telemetry data could be an agent installed in a system like Splunk, and it feeds the data, and then you start looking at that feedback, right? The OS level parameters are captured, it goes to a command center, and then you start looking at the common dimensions, because you're trying to look at categorization of all these data, right? Your historical information of incidents, your problem records, your known errors. It could be a plethora of information, right? That could rely on your ServiceNow systems, it could rely on your Jira tickets, it could handle in various aspects. It is up to you, right? But I want to start understanding the patterns of grouping it, and then say, is this isolated incident, or is it a repetitive incident? Is it happening for the first time, or is it happening many times? I ask this question a lot of times in my workshops, asking how many of your incidents are repeatedly occurring, right? If I ask you, out of 100% incidents, how many incidents are repeatedly occurring? Most of the people say that there is about 85% of incidents are um, are repeat incidents. Only 15% is about new incidents. That means you fairly have an idea about 85% of the issues that are happen on a daily basis. So that should give you an insight about looking at the entire gamut and seeing how we can manage the overall analysis, because it's important to understand the intent of an analysis, right? Is it not a check in the box, or what are we trying to do that will enhance the overall experience, right? So that comes to the point of what we call as monitoring versus observability. Now, I think this was a very easy graph for everybody to understand the difference between monitoring and observability. Now, if you look at the monitoring, which is showing you symptoms, it has alerting mechanisms where you define your thresholds. It helps you to understand the service health. It looks at the investigation part. It's done all the time because typically the operations team or the support team manages this. It's very passive because why? Only when the threshold gets increased will it actually show something. Otherwise, it's no brainer. It just is business as usual, right? And it's managed by ops. Whereas in observability, we look at debugging, profiling, dependency analysis, which is more like a distributed tracing if you're having microservices, where we look at metrics, events, logs, and trace. Now, today what's happening, we look at observability only when something is broken, right? If it's a P1 incident, we are in a major incident which calls, you look at on the fly, you bring the developers to go through the piece of code and find out what else would have broken, right? So it's very reactive when there is a P1 incident, and then it's typically managed by the dev team. So from the right to the left, it takes time. Now it's very reactive. Ideally, your observability will have to become more proactive, right? Because with all the historical information and patterns, you should start understanding the known knowns, known unknowns, and then get to that part of preempting something, right? So while monitoring is telling you a set of what's broken, the observability is trying to attempt the causes. There could be one to many reasons why something is failing, and that could give you an insights of how we should handle that overall, right? So what are some of the key benefits of observability? The benefits of observability from monitoring is, first of all, at the end-to-end value chain, it creates high visibility. Whether it's a developer, operation person, testing person, you know exactly what you need. It has curates the overall workflow better because right now you are managing distributed environments. Your ability to predict alerts gets important. We are looking at unknown unknowns. We already talked about it. You reduce operation cost, and more importantly, because we are getting into the predictive mode, you are trying to improve the user experience because you are improving their experience every day, right? So there is definitively key benefits of observability that I see organizations embarking on. So I wouldn't be surprised why you shouldn't do it if you're not done earlier, right? Now, before you start getting into observability, I want you to ask this question very clearly. As part of your current infrastructure monitoring or application monitoring, what are the golden signals of monitoring? This is bare minimum important, right? So we talk about logs, events, metrics, and tracings. So if I look at this graph, this pyramid is what I call as the Google's golden signals. And for me, every support operations team should bare minimum do these aspects of data, right? So traffic, your throughput, number of concurrent users at a time, errors, you get 400, 500 errors, pretty frustrating, particularly in an e-commerce kind of environment. Latency, how much time does it take to load your page? And saturation is like a thread. You're able to you're not able to process the thread and you have to kill it, right? And it has come to a saturation where it will not allow further requests to be supported, right? So from a metric standpoint, right, we need to start looking at your use metrics, which is your utilization, saturation, errors. Demand, which is how much requests are you able to handle in the system? What are the errors? How much duration does it take? Is it a 500 milliseconds or a 300 milliseconds? What is the level of percentile? One of the things we tell about in SRE is not to look at percentage because, and also averages lie. So you need to look at percentile of data, which is more closer. So you need to look at 90th percentile, 95th percentile, 99th percentile. So you have a broader understanding about this whole demand aspect of it. From a business standpoint, a lot of times we need to focus on business metrics. So if you're an e-commerce channel company, you look at how much of the checkouts were abandoned, how much were the customer churn out, how much is the revenue per location. So you should not look at this more from an IT centric. We should also look at how the business approaches. So for me, before you deep dive into observability, I would want you to do this very diligently, right? And I had a kind of a resource that I share in my workshop. right? You can have a golden signals of monitoring on load balancer, on the server level. So you can define on the different parameters how the golden signals of monitoring can be implemented, right? So the question is about building better insights to your system. So please make sure that you're doing this well enough for you to deep move into the observability space, right? So what does a maturity model look like if I want to understand how are organizations stepping up this whole curve? I would start with monitoring, which is your basic level of monitoring that you should have in place, which is either an infra monitoring that you're having in cross or application monitoring. The observability part is where we talk about your metrics, logs, and traces. In this level, there is a little bit of microservices because there is a distributed tracing available. Causal observability is where we need to focus on timeline and topology. Typically your topology is your upstreams and downstreams of your system, right? So, for example, an email service is supported by an Exchange server, supported by a web server, app server, database server. So you need to look at the entire topology and see at every level, right? As we create the visibility across the value chain, how am I progressing from one level to another level, right? So for me, that is what I call as causal observability. And the final one is to make it more predictable, right? So the only way that you can make it more predictable is when you have AOps, because there's a lot of promise that is happening today with AOps making it more predictable, so that we are able to preempt some of the issues before they happen. Right. So this is a maturity model as a start that you can think about. This is from Stack State. So you decide as a company where you are, and it's a marathon, right? It's not just immediately you move from monitoring to observability. So one of the things is also about the prerequisites. So prerequisites is to start thinking about your golden signals and then move forward in the value chain. Okay, I hope this observability maturity model is useful. So what are the components of observability, right? So if I break this into elements, you have a UI component, which is the user interface in which users are able to interact. There is a storage component. Then you process the information that will go on the backside through libraries, agents, and propagating that information, correct? So if you look at the breaking down into the parts of the different components, I can manage my user interface and storage into one dimension. Then I can put the rest of the things about library agents, processing, propagation into another production network, because I'm also being quite focused on my um, operating window in terms of performance, right? So you can have your transmission protocol, storage UI separately, the rest of the ones separately. So I can have two identical boxes that I can host this, right? Now, when you start looking at your toolchain aspects in your pipeline, you might use this one, and this is going back to your earlier conversation that we are talking about Prometheus. You can use your Elasticsearch, Logstash, Kibana as one of them, right? So your Kibana is going to be a part of user interface, your Elasticsearch for storage, Logstash for this whole processing, right? So I'm trying to give examples of open source so that you're kind of familiar with that. And as you know, if you are an SRE or even for the developer, I would definitely recommend you to become a member of Cloud Native Computing Foundation, CNCF, because you're doing some great pioneering work and you can be a part of that think tank team to do it, right? Now, what does it take you from moving from monitoring to observability, right? So if I need to move and I given some tools that are available. There is no specific one. You have Splunk, Elasticsearch, App Dynamics, Dynatrace, New Relic, Instana, Datadog, Honeycomb, Lightstep. I've just given a plethora of this, right? The first and foremost thing is to identify whether you're tracking your metrics, traces, and logs, right? If you're not even tracking at that metrics, traces, and logs, then it's too much of an ask, right? Then are you using open telemetry? Because that's going to give you a lot more advantage, because you remember we talked about instrumentation. Open telemetry from the Cloud Native Computing Foundation allows you to, we call as OTel, will give you an opportunity to do auto instrumentation. Then you look at AI, machine learning to prioritize data. Then start thinking about the auto remediation, because that's the icing on the cake, right? The moment you start understanding the pattern of behavior, look out one, two possible reasons, nail down that issue, then start creating that script, playbook, auto remediation, self-healing options so that the next time it doesn't happen, right? So I think that's the highest level of nirvana that we are aiming. In fact, in the next 2 to 3 years, I don't think we will have anything called monitoring. It will all converge into one single source called observability, because ideally what we are doing, we are trying to pull all of those stuff together. And that's predominantly how this is going to change gears. So I told you that we need to go from reactive to proactive to predictive. So how are we going to accomplish this in your observability factor, right? So you have your historical real-time data that is coming from different sources like monitoring, your ServiceNow systems, Jira, your data logs, and then that could feed into this whole observability paradigm, right? So all your open source proprietary tools, third-party APIs, web services, everything feeding into right, real user monitoring, synthetic monitoring. That will feed into what I call as the data lake, right? We will create a data lake, and from there you will start looking at AOps, which is an ability to look at predictability. And ideally, what should happen is as we start to shift gears using AOps, it should give you an opportunity to self-heal your applications. You should help you to auto remediate certain things. It will help you to add business value and then address business KPIs. So that's the world that the business is expecting you to do, right? So you have to decide as an organization whether you are still in the monitoring aspect of it or you've started on observability, and AOps is going to accelerate the overall observability part of it, right? And there are a lot of sophisticated tools. We are not trying to tell it's for or against, but the whole aspect is to understand where are you in the journey and what does it take you to move into become the reliability as a first class citizen in terms of maturity. Yeah. So that brings to our next important topic called open telemetry. We call as OTEL. So I've just given a very pictorial representation of open telemetry. There's a whole lot of resources that are available, which I will strongly encourage you to look into it. On the open telemetry aspect of it, if you look at it, the pipeline architecture. So basically there are three parts. There is a client, there is a collector, there is a storage, right? So there are options for you to interact with open source tools to see how the system behaves, right? So you're trying to get a little more deeper insight of how things are working on the place. So what would mean is that you can use like Agar, you look at Prometheus, you look at Zipkin, and the whole world will just make your life a lot more easier than what it is today, right? Because it gives you a level of visibility, right, in terms of traceability. So you know exactly what is a culprit, right? Remember in the earlier days we said that, okay, there is one query that is taking way too much time. We call as the slowest performance tuning query that we need to do. But now it is going to give you a visibility, okay, which application, which function is creating the problem so that we will be able to nail down the issues faster in the value chain rather than just thinking and waiting for something to happen, right? So what are some of the observability challenges? Now, the first and foremost challenge that I see is that people lose customer focus, right? So a lot of times they are very focused on your metrics, logs, traces. But what are we doing? Why are we doing this in the first place? Our focus is to ensure better customer experience. So do not lose customer focus, right? These are all a means to an end. It's not an end by itself. We have too many traces and unnecessary alerts that like false positives, fatigueness. It creates that whole ruckus in terms of having fatigueness and noise about certain things. And another issue that I see is that all the environments like the dev environment, QA environment, test environment, even the pre-production environment, they are not even similar to a production environment. So ability to replicate issues also become very difficult. So the environment and inconsistency also provides a big challenge to implement observability. Then there is a plague of dashboards. We already talked about watermelon syndrome, right? Each and every one shows a big dashboards. So be very clear about what you are measuring. It's not about measuring everything. Focus on two or three key parameters that makes the most sense and then do it, right? So, and a lot of times what I've seen is that as people start becoming so obsessed with metrics, they're trying to gamify the metric. they know how to get it done. So that has lost the meaning if you are not really looking at it. And just because you had a metric earlier doesn't mean that you have to have the same metric. I have this issue that I ask people that, I was one of the customer that I asked was, how many reports do you read? I asked a CIO, he said 42 reports. And I said, how many reports do you read? Actually, 2 reports. And what about the other 40 reports? They say that, these people have been sending these reports for a long period of time and they continue to send that. So there's no meaning in that. So constantly ask this question, is it still relevant? Is it making sense? And then do it. And the last is a shiny tool, because people think that, oh, I bought this tool and then everything will become magical, right? So it doesn't work, right? So if your ecosystem is not curated, if the principles and practices are not embedded, if the people are not enabled with that structure, you're going to struggle big time. And these are some of the common challenges, I think, that you need to be aware when you're trying to implement observability, right? So my last slide is observability tool recommendation. So the first and foremost thing, it's okay that you pick up any tool of your choice, but look at user-friendly interface, that is ease of navigation and commercial value, right? A lot of times you should be able to do it on your run, right? A lot of times we talk about no code, low code, right? So you as a company who acquires a tool should be able to play it out without too much of professional services help that is needed, right? It should supply real-time data, because in spite of whether you're using your proprietary tool or open source tool, you should be able to curate feedback from other systems so that you have a single view of the observability aspect of it. So you should be supporting open source agents, because hotel is becoming big time. Easy to implement, right? Because I don't want to spend enough amount of time to learn a tool by the time the time is already lost, right? And whatever be your current stack, your languages, your containers, it should be compatible, right? Because don't do this problem of having a um, uh, different tool chains, right? So focus on minimum number of tool set that are complementing each other, and ask the right question whether it still makes sense or not, because your company would have done some due diligence of picking up the right tool in moving forward, right? So finally, the way I look at the digital operating model that should bring in the overall scheme is at the top we have the DevOps and SRE aspect, which is all your dashboards that you see, your APM monitoring tools. So the blue ones, the dark blue ones, are the legacy IT monitoring one. The light blue ones are the new ones, which is based on self-service analytics and stuff like that. So you look at log, APM monitoring and middleware, third level support, synthetic monitoring. These are all part of the older way of legacy monitoring. Now with the level of moving towards observability, we are starting to look at AOps, we're looking at microservices, you're looking at open telemetry, you're trying to look at Kubernetes and OpenShift to see how we can build that observability data collection layer. Because this is going to be the most important part, because you need to have underlying data layers that validates and tells you meaningful information that you can leverage and showcase value towards the overall digital operating model. So think about this big picture view, see where you are already there, try to facilitate this observability data collection layer, and guess what? You will become on your path to glory towards making that operation successful.